Come on my dears, here we are given 6 measured values of absolute refractive index of a particular transparent medium, correct? Those 6 measured values we are showing by symbols A1, A2, A3, A4, A5, A6, and they are respectively 1.54, 1.53, 1.44, 1.54, 1.56, 1.45. Okay? Now these are the values of refractive indices, correct? What is called absolute refractive index that you will study in 3rd semester. At present, let me give you some simple introduction. It is a ratio of velocity of light ray in vacuum to the velocity of light ray in a given transparent medium. Such a ratio is called absolute refractive index of a given transparent medium for a given frequency of light ray. Okay, fine. It is unitless and hence dimensionless also. Because it is unitless, I am not writing any unit here. Okay. Now, in this measurements, we are supposed to find out absolute error, then after relative error, then after percentage error. Okay. Let us find out one by one. First of all, we find out average value. Okay. It is nothing but A bar, and it is summation of given observations divided by number of observations. Here number of observations is 6 and summation will be A1 plus A2 plus A3 plus A4 plus A5 plus A6, that divided by 6 will give me average value of given observations. Let it be A bar. Come on, A1 plus A2 plus A3 plus A4 plus A5 plus A6, that is summation of all these 6 values. It will be summation of all these 6 values and it is 9.06. That divided by 6 will be 1.51. Okay. Because refractive index is unitless, I am not writing any unit here. Okay. Now let us find out absolute errors in different observations separately, independently. In the first observation, the absolute error is delta A1, it is A bar minus A1. A bar is 1.51 minus A1 is 1.54. Subtraction is minus 0.03. Similarly, absolute error in second observation is delta A2 equals to A bar minus A2. A bar is 1.51 minus A2 is 1.53. This minus this is minus 0.02. Come on. Absolute error in third measurement is delta A3. It is A bar minus A3. Come on. A bar is 1.51 minus A3 is 1.44. The subtraction comes out to be plus 0.07. Now absolute error in the fourth observation is delta A4 equals to A bar minus A4. A bar is 1.51 minus A4 is 1.54. 1.51 minus 1.54 comes out to be minus 0.03. Absolute error in the fifth observation is delta A5 equals to A bar minus A5. A bar is 1.51 minus A5 is 1.56. This minus this comes out to be minus 0.05. Come on, absolute error in the sixth observation is delta A6 equals to A bar minus A6. A bar is 1.51 minus A6 is 1.45. This minus this comes out to be plus 0.06. Okay. Now let us find out average absolute error. Average absolute error. It is delta A bar. It is nothing but summation of magnitudes of all the absolute errors divided by number of observation. Come on. Summation of moduluses of all the absolute errors, that is mod of delta A1 plus mod of delta A2 plus mod of delta A3 plus mod of delta A4 plus mod of delta A5 plus mod of delta A6, that divided by total number of observations is right now 6. Okay. When you take modulus, you are supposed to convert negative value into positive value. Okay. Whichever value is positive, just keep it as it is, but whichever value is negative, when you take modulus, it will become positive. So with plus signs, you should take the addition of all these values with plus sign, and then after that summation should be divided by 6. Now this summation comes out to be 0.26, that divided by 6 comes out to be 0.0433. But here all these values have second decimal place, that is there are 2 digits after decimal point, correct? So we must round off this figure up to second decimal place, that is we should retain only 2 digits after decimal point. So if you want to keep only these 2 digits after this decimal point, then this 3 is to be discarded, correct? It is to be dropped down. Then for that you just see this digit, it is 3, which is less than 5. Because it is less than 5, we can just drop it straight away. When you drop it, it will be 0.04, 0.04. When you make it rounded off, this figure will turn out to be this figure, 0.04, which has 2 digits after decimal point, okay? Now let us find out relative error or partial error or fractional error. Relative or partial or fractional error, it is delta A bar upon A bar. Delta A bar upon A bar. What is delta A bar? Delta A bar is 0.04 divided by A bar. A bar is right now 1.51, correct? Now this upon this comes out to be 0.02649, 0.02649. But here also we must retain only 2 digits after decimal point. That is, this 6 is to be dropped down, and when you want to drop this 6 itself, it is greater than 5. Because this 6 is greater than 5, we should add 1 in the previous digit. When you add 1 in this digit, it will be 3 here, so it is now 0.03. That's why this is approximately equal to 0.03, correct? So you are just making it rounded off up to second decimal place, okay? Fine. Now let us find out percentage error. Percentage error is nothing but relative error multiplied by 100%. Relative error we have found out, it is 0.03 multiplied by 100%, it will be 3%, 3%, okay? My dears, the sum which they have asked in the textbook is getting finished here, okay? But by chance, if they ask to represent the final measurement, how would you represent it? I am showing you. Tell me here, what have you found out? You have found out refractive index, correct? Normally it is shown by symbol small n, okay? Now there are 2 ways you can express the final measurement. In first way, you are supposed to write first of all average value plus or minus average absolute error, okay? And in the second way, first of all you should write down average value plus or minus percentage error, correct? So let us write down final measurement in this case. Come on. In first method, what you will write down first of all? Average value. Average value is right now 1.51, correct? Plus or minus, you are supposed to write down average absolute error. And average absolute error we have found out, it is 0.04, 0.04, correct? And because refractive index is unitless, I am not writing any unit here. Got it? What is the second way? In the second way, first of all you write down average value, it is 1.51 plus or minus percentage error. Percentage error right now it is 3%. So I am writing plus or minus 3%. Okay? Please remember this method. Okay? Fine.
Read number 4. Number 4.